Hi, welcome to another lesson on organic chemistry with Dr. Hill. Today I'm going to talk about naming the alkanes, because it's about time we started getting some names for these different compounds. Otherwise they're going to be hard to talk about. So we're going to look at how alkanes are named, the simple straight chain alkanes. We'll look at how they're named, and I've got about 10 minutes to do it in. Okay, so the first thing is I want to show you some models. Remember we drew this alkane that just has a single carbon in it. And when we drew it on a flat screen, on a flat piece of paper, we drew bonds coming out in 2 dimensions. But in reality, these things are 3-dimensional. And in fact, there's not a lot of reality in this either, because in this particular model, I have very long bonds between the 2 atoms, the carbon atom and the hydrogen atom. It shows a very long bond. In reality, it's probably more like this, because the atoms are sharing electrons, so their structure gets much tighter. So that would also be this single carbon alkane. So and we also notice that this structure, and I'll show it to you when we're on the board, is what we call the tetrahedral structure. The tetrahedral structure. It's got an atom in the center, and it has 4 atoms that come out on each side. Now, the geometry of organic compounds isn't something that we're going to worry about too much in National 5. So what we need to do is come up with names for these things. As I say, I've been calling this the 1-carbon alkane for the moment, but you may already remember that this is called methane, this molecule. We've talked about it as an example of our tetrahedral shape. So this methane molecule is named according to a system. When it has 1 carbon, it gets the prefix METH, meth or meth, depending on, some people pronounce it methane, some people pronounce it methane. And because it is saturated, i.e. there's no room for any more hydrogen in this molecule, because it's saturated, it's an alkane, and it gets the suffix ANE. So we put the 2 together, meth or meth and ANE, and we get methane. All right. Now, as we go up, 2 carbons gets a different name, ETH, not METH. So if I had 2 carbons here, it would be ethane, ETHANE, ETH the prefix, ANE the suffix for an alkane, a saturated hydrocarbon. We can move up to 3 carbons. I've got a model of 3 carbons here. I haven't made a model of all of these because I'll run out of parts. But I've made a model of my 3-carbon alkane. As you can see, all single bonds, no room for any more hydrogen in this molecule. It's saturated and it's got 3 carbons, which gets the prefix prop or prop. It's an alkane, so it gets the suffix ANE. So this is propane. Okay, we move up. The next one up will be butane for 4, etc., etc., all the way up to this one here, which is as far as we're going to go, with 8 carbons in it. 1, 2, 3, 4, 5, 6, 7, 8 carbons in it. And it's a very flexible structure, as you can see. And this is really, to some extent, the flexibility that we will see in nature. And these 8 carbons gets the name oct. Now, once we get past 4, the naming becomes a little bit easier, because it becomes the same naming that you use for geometric shapes. So 5 carbons is pent, 6 carbons is hex, like hexagon, 7 carbons is hept, like heptagon, and 8 carbons is oct, like octagon. So let's have a look at the naming system on the board, and we'll nip over here and have a quick look. And again, so we've got our 1-carbon structure. Here it is, 3-dimensional. So if we were drawing this out in 2 dimensions, of course, it looks like that. So that is how we represent this. But remember that they are 3-dimensional, not 2-dimensional in reality. The trouble is we can't write on 3-dimensional paper, so we have to use a 2-dimensional diagram. Now here is the naming of the alkanes. Very, very straightforward. In this column, I've got the number of carbons in the chain. Right, we haven't got any branches in these chains. We'll talk about those in another lesson. And for very simply, the prefix that we use is meth, eth, prop, but, pent, hex, hept, oct. Remember, these ones here are the same as geometric shapes. These ones here are the tricky ones to remember. Methane and ethane are relatively easy to remember because we see them a lot. Methanol, ethanol, we see a lot of these compounds, so we tend to remember this. Propane and butane are a little bit harder to remember, that prop is 3 and but is 4. The suffix for all the alkanes is ane. This means that they are saturated, no room for any more hydrogen. And then we put the two together, meth and ane, and we get methane. Eth and ane, we get ethane. Prop and ane, we get propane. But and ane, we get butane. Pentane, hexane, heptane, octane. So now we can name an alkane of any number of carbons up to 8. So I can stop referring to this thing as an alkane with 1 carbon, and I can start calling it methane. I can stop referring to this thing as a hydrocarbon with 8, or as an alkane with 8 carbons, and I can now call it octane. Okay, that's octane, and in fact you can see it wraps up. Now remember that these structures are more likely to be more densely packed than these kind of models here, more likely to be more densely packed because they're sharing electrons. This is probably more of a representation of an ionic bond where electrostatic attraction is pulling atoms together, but this is not an ionic bond, it's a covalent bond. So the electron shells of the atoms actually overlap, so it looks much more like this. This, by the way, with 3 carbons will be propane, propane. No room for any more hydrogen, so it's saturated, single bonds everywhere. That's propane. Okay. Now the reason we don't build them like this is more realistic really, is because we can't really show single bonds, double bonds and triple bonds in this kind of model. That bond there can't be represented any other way with this space filling kind of model. Anyway, I hope that was useful to you. What we're going to do now is we're going to talk about the properties of the alkanes, and we'll look at some of the reactions that they may or may not take part in another lesson. And we'll move on to different types of alkanes. We're going to look at what happens when they branch, because as you can see, a carbon doesn't have to bond to just 1 carbon either side. It could bond to a 3rd carbon and leave only 1 bond for hydrogen. So that will give us a branch, and we'll look at that in our next lesson. So hopefully that's useful to you. You now know how to name the alkanes, and I'll say goodbye, and hopefully I've done it in less than 10 minutes.